Welcome to our discussion on sets and subsets. So without further ado, let's get started. What is a set? Well, a set is just a collection of objects, where the objects that make up the set are called elements. And so some examples of these things, let's look in front of you. You probably have a keyboard and a chair of some sort, maybe even a monitor. And so if we put those inside of curly brackets, so you see the curly brackets on the left and right of those three words, all of a sudden we've created a set. Now it doesn't just stop there. We can create other sets. So we had the set A above, and now we can create the set B. Now we're going to use a different notation. We'll put the curly brackets and we'll put an X, and the way this is read, that line there means such that. So X such that X is a US state beginning with the letter A. And another way we could kind of look at another set, let's say C equals the set of Alabama, Alaska, Arizona, and Arkansas. Well, if you notice, B and C are actually the same exact set. We just wrote them in different ways. And this is, we have one being set builder notation and another one being where we actually list the elements. So B is the set builder, C is where we're listing the elements. You can see all formats of sets throughout this section. So now, moving forward, we just say that two sets are equal if they contain exactly the same elements. So moving forward from there, some sets that we're going to deal with often in this class are the set of natural numbers. So the set of natural numbers are just what we learn to count. We start with 1, 2, 3, so on and so forth. That's our natural numbers. And if you toss in a 0 into that set, you've got the whole numbers. So 0, 1, 2, 3, and you keep on counting on up. That's the whole numbers. The integers, we take 0, 1, 2, 3, and then we toss in the negatives of all those. So you get negative 1, negative 2, negative 3, so on and so forth towards negative infinity, and then you get 0, 1, 2, 3 all the way towards positive infinity. And combining those, we can start to build some fractions from integers. And what are we looking at? We're looking at the rational numbers. And those are the set of numbers x over y, such that x is an integer, y is an integer, with y can't be 0 because we can't divide by 0. And x over y is in reduced form. So meaning if you have two common factors, you've reduced that on out. So some examples of rational numbers, just to make sure we're on the same page here, and irrational numbers, which is things that are not rational. One example would be 31 over 7, and that's due to 31 and 7 both being an integer. On the other hand, for irrational number, you could look at, say, pi. Pi does not have an integer over an integer format, so not rational, meaning it's an irrational. 1/2 would be an example of a rational number because you have an integer over an integer once again. Square root of 5, though, is not, because once again, then we don't have an integer over an integer. However, if you look at 6, you might say, oh no, it's not a rational number, but actually it is, because 6 is 6 over 1 when written in that fraction format. So we just reduced it to 6 to make it simple on ourselves. However, cube root of 9, for example, that one is not a rational number, so it's an irrational number. So now you see some examples of what's rational, what's not rational. And moving forward from there, what do we actually want to look at? Well, we want to look at these things called subsets. So a set A is called a subset of a set B if all the elements of A are elements of the set B. And then we have this fancy notation where it looks like a C with an underline, meaning equal, being a possibility, for the notation to denote that A is just a subset of B. Now, examples of this. So if we let B be the set of all, let's say, animals in the animal kingdom, and let A be the set of all, say, mammals, then A is definitely a subset of B. Okay, moving forward, the natural numbers, so we just dealt with that. That's a subset of the integers because you have 1, 2, 3, 4. That's obviously going to be involved in something where you have 0, 1, 2, 3, 4, so on and so forth for those numbers, along with the negatives, so that's always a subset. If you're looking for something that's not a subset, 1, 2a is not a subset of 1, 2, 3, 4, 5. And now, if we wanted to list all the subsets of, say, A, B, C, well, you could get the set containing the element A, the set containing the element B, the set containing the element C, the set containing the element AB, the set containing the elements A and C, the sets containing the elements B and C, and the set containing elements A, B, and C, and last but not least, the set containing no elements. That seems kind of a vacuous statement, but actually all of those are all subsets of A, B, and C, the set containing ABC, I should say. And in fact, that's all of them. That's all that there are to it. You can't find any more subsets. So hopefully this gives you an idea of how to work these problems and determine sets, subsets, and all that song and dance. If you have any other questions, please do not hesitate to ask.